Hi everybody, this is Mrs. G. Today we're going to start some trigonometry, and specifically today we're going to learn about angles of rotation. So before we get started, I do have a warm-up, which is some geometry review, which we'll definitely need in today's lesson. So you can see we have some right triangle trigonometry here, so give these a try. Pause the video and we'll check your answers in just a few moments. All right, go ahead and check your work here. So for part A, this is an example of a time where you can use Pythagorean theorem, a squared plus b squared equals c squared, to solve for a missing side. The important thing to remember with this is that your hypotenuse, which is always opposite the 90-degree angle, must be the c value. A and b are interchangeable. So here you end up with square root of 180, which simplifies to 6 root 5. For parts B and C, we have special right triangles, so 45, 45, 90, or a 30, 60, 90. So we can actually find missing side lengths by creating ratios because these are similar triangles. So remember, you do the ratio of the corresponding parts. So for example, in part B, I see that the side length of 7 corresponds to the side length of 1, and then the missing side x corresponds to this root 2. So 7 over 1 equals x over root 2, and then you can solve for x. For part C, I can see that x corresponds with this side length of 1 because it's opposite 30, so be careful. And then I see that 10 corresponds with with 2, so we can say x over 1 equals 10 over 2. And then I see that our y value at the bottom corresponds with the length root 3 because it's opposite of 60. So y over root 3 equals 10 over 2. So we get 5 root 3. And then the last one we can solve using SOHCAHTOA. So here it's not a special right triangle, but we do have an angle and one of the lengths. So in this case, what we have is the opposite, because it's across from where the angle is that we're working with, and we have the hypotenuse, because it's across from our 90-degree angle. So we say, oh, sine is opposite over hypotenuse. So the sine of 40 degrees is x over 12, and then we solve for x, and here's our decimal approximation. So we'll be using all of these things throughout our trigonometry unit, so make sure, if you need a little extra review, go back and review some of these concepts from geometry. All right, so we're going to start off with some trigonometry vocabulary that we're going to be using throughout the unit. So the first one is called the angle of rotation. So it's simply a ray that's rotated about its endpoint to create an angle, which can be measured in two different units. We measure angles in either degrees, which we'll start with today, or radians, which we'll talk about in the next lesson. So you can see here's an example of an angle of rotation. You take this ray and you just rotate it to create some angle. So the initial side is the starting position of the angle. So in this case, our initial side is right here on the positive x-axis, and the terminal side is what we call the ending position. So initial and terminal. For standard position of an angle, so this is how we will be drawing all of our angles from here on out. The standard position is when the endpoint of the ray is at the origin. So you can see, like it is here, here's your ray. Our endpoint is at the origin, so it's centered. And the initial side is always going to be that positive x-axis. So technically the initial side could be anywhere, but for standard position, we are always going to start here and then either rotate counterclockwise or clockwise. So for trigonometry, we are going to be working with the 4 quadrants on our axes. These 4 regions or quadrants are numbered 1, 2, 3, 4 in Roman numeral. And they are numbered in a counterclockwise direction. So you can see here how your quadrants are numbered. This is our first quadrant, and then again moving counterclockwise, quadrant 2, quadrant 3, and quadrant 4. And we do use these Roman numerals. Okay, so our next vocab term is a quadrant angle. So a quadrant angle is an angle whose terminal side is actually on one of your axes. It's on an axis. So here maybe you have an angle that's on the positive y-axis or the negative x-axis. Again, we call that a quadrant angle. So it's one that's not in between. If you have a positive angles are going to always rotate counterclockwise. And if you have a negative angle, all that means is that you are instead rotating the other way. So you're actually rotating clockwise. Coterminal angles, something we'll be using today, are two angles that have different measurements, but they have the same initial and terminal side. So it looks like, well, they are falling in exactly the same spot, but their angle measurements are different. So we'll talk about how you can find those today. And then our last term is actually the most common variable we use for trigonometry, and that's theta. So it looks like this. You'll see it right here. This is the Greek letter that is probably most commonly used as a variable for angles. You can name an angle anything, but theta is the one that we're going to use the most, so I just want to make sure you know how to read that. All right, so let's start with talking about how to draw a positive angle. So a full rotation around the axis has 360 degrees. Okay, so we're going to see if we can first use logic to determine the measurements of our axes, and then we can talk about how to draw our angle. So again, our initial side is always going to be that positive x-axis, so that's 0 degrees. And then actually, if we do a full rotation all the way around and we get back to here, that we could also call 360 degrees. So it's kind of an example of two coterminal angles. They're in the same spot, but they have two different measurements. So again, a full rotation is 360. So let's use some logic. Well, if a full circle is 360, half a circle will be 180. And then half of that would be 90. So you can see our axes are every 90 degrees. So that means that this must be 270. So if I'm asking you to draw an angle, you pretty much determine, is it between 0 and 90, 90 to 180, 180 to 270, or 270 to 360, and that will help you place it. So let's start by drawing 120. So I can see 120 is between 90 and 180, so it must be in quadrant 2, and we draw it like this. So you can kind of estimate where that would be. And then we connect a little arc from our initial side to our terminal side, and we can label it 120 degrees. And you can see that that falls in quadrant 2. So you can say Q2. All right, let's do 350. So I see 350 degrees is between 270 and 360. So, and it's actually pretty close to 360, so maybe I'll draw it around here. And again, I can draw a little arc going all the way around to here, and we'll say 350 degrees. So we can see this falls in quadrant 4. All right, now let's draw 40 degrees. So 40 degrees is between 0 and 90, so it's going to be in quadrant 1. So maybe it looks something like this. 40 degrees, quadrant 1. And then let's try 200 degrees. So that's between 180 and 270. So maybe right around here. And we could draw our little arc and then label it 200 degrees. There you go. And again, this is in quadrant 3. So we can see that quadrant 1 is anything that's between 0 degrees and 90 degrees. Quadrant 2 is between 90 degrees and 180 degrees. Quadrant 3 is between 180 and 270 degrees. And quadrant 4 is between 270 and 360. All right, so now we're going to try drawing some more angles, but this time they're going to be negative angles. So I want to remind you that negative angles, they're going to act the same way, except this time they're actually going to move in that clockwise direction. So they move in the opposite direction. So let's see if we can do the same thing with logic and figure out the measurement of our axes with negative measurements. So 0 is still going to be on that positive x-axis, and a full rotation is still going to be 360 degrees, but we'll call it negative 360 degrees. And then we're going to break it down in the same way. So half a circle in the negative direction will be negative 180. Half of that will be down here, negative 90, so this is negative 270. So you can see it's the same measurements, except they're occurring in the clockwise direction. So let's see if we can draw these different negative angles. Let's start with negative 25. So that's going to be between 0 and negative 90, so maybe right around here. And we could draw our little arch and say negative 25 degrees. And this is going to be in quadrant 4. The quadrants are still labeled the same. Now let's do negative 285. So that's going to be between negative 270 and negative 360. So let's draw that in quadrant 1. And it looks something like this. So that's negative 285. Let's do negative 190. So that's going to be between negative 180 and negative 270. So we can draw that here in quadrant 2, like this. So that's negative 190. And then negative 100, we can see is between negative 90 and negative 180. So let's draw that here. And that's going to be in quadrant 3. So again, this was quadrant 3. Part D fell in quadrant 2. And the second part, sorry, they are mislabeled, falls in quadrant 1. So if we're determining the angle measurements for each quadrant using negative angles, if we're in quadrant 1, it's negative 360 to negative 270. Remember, negative 360 is actually smaller, so we should put that on the left. For quadrant 2, it's negative 270 to negative 180. For quadrant 3, it's negative 180 to negative 90. And for quadrant 4, it's negative 90 to 0. So again, it's broken down in the same way, it's just moving in that clockwise direction. All right, so now we're going to talk about how to find coterminal angles. So remember, those are angles that have different measurements but fall in the same place. So they have the same initial and terminal side, and they look exactly the same. So we can find terminal angles, they're pretty easy to find, simply by adding or subtracting 360 degrees. So we're essentially going a full rotation forward or backwards. So for each one, we're going to find one positive and one negative coterminal angle, and then we're going to graph each angle. So let's start with 75 degrees. So if I have 75 degrees, we know that falls in quadrant 1. So here's 75 degrees. Now if we want to find those coterminal angles, again, we just take 75 and we can add 360. So we go a full rotation in the positive direction and we get 435 degrees. So again, it falls in the same spot, but the way that you can show that it's different is you can actually go all the way around plus some. So that shows that it's that coterminal angle that's larger, so 435. So 435 is what's in red. 75 degrees is what's in the blue arc. And then let's find a negative coterminal angle. So again, we're just going to subtract 360. So we're going to go 360 in the opposite direction. Should still fall in the same place. And we get negative 285 degrees. And we can show that just by simply moving our arc in that opposite direction. So I'll do this with green. So like this. There we go. So green is negative 285. So the little swirls that we can use can show actually help us determine what the measurement is. So by how many times they've been around and if they're moving in the positive or negative direction. All right, so let's try negative 270. So we can find, or let's start by plotting this. I'll draw another axis down here. So negative 270 is actually one of those quadrant angles. So remember, I'm moving in the negative direction and it goes to here. So we can actually draw it just like this. So we draw it on top of our positive y-axis. We're going to draw it like this. So that's negative 270 in blue. So let's start by finding a positive coterminal angle. So we can start by adding 360, and then we should get 90 degrees. And again, we can show that with our arc, so we can go like this. So the red is how we draw 90, so from here to here. And then we need another negative coterminal angle. So we can take our original angle, negative 270, and we're going to subtract 360. And we get negative 630. So again, falls in the same location. We can show this by doing that full rotation. So I'm going to go all the way around, and then we're going to go around again like this. So we did a full negative rotation and then another one. Okay, let's look at part C. So here we have 500 degrees. So we could add 360 to get another positive coterminal angle, but we could actually subtract 360 and it would still be positive. So I'm going to do that just as an option. There's actually an infinite number of answers you could give. So 140 degrees would work. I'm going to do this one down here. So this is part A, this one's part B, here's part C. Okay, so 500 degrees is actually a full rotation plus the 140, so that does fall in quadrant 2, so it's somewhere around here. So it actually is probably a good idea to find that smaller positive angle so you know where to graph it, because 500, it might take you some time to figure out where that would be. So to graph 500, again, that's bigger than a full rotation, so we go all the way around plus some. So the blue represents 500 degrees. I'll do red represents a positive 140, so it's just from here to here. And then let's find a negative coterminal angle. So I'll work with 140, and then from that I will subtract 360. And we get negative 220 degrees. Again, we can show that just by moving our arc in that negative direction. And there you go. Okay, and last we have 1,250. So this one is actually a couple rotations around. So we do want to figure out first what quadrant that's going to fall in so we can graph it. So we are going to need to start subtracting full rotations so we get an angle that we can work with. So let's start by subtracting 360 degrees, and we get 890. So I still don't know where that would fall. So let's take off another rotation. Let's do minus 360, and we get 530. And that still is bigger than a full rotation, which is fine, but for us to graph it, let's take off another 360. And then we get 170 degrees. So that's easier for us to plot. We can plot that in quadrant 2. Now, if I'm going to draw this first angle, notice that it's 1 rotation, 2 rotation, 3 rotations plus 170. So we have to go 1, 2, 3 plus the 170. So that's how you would sketch 1,250 degrees. Now, all of these are actually positive coterminal angles. 890 works, 530 works, 170 works. They're all coterminal. I'll just show 170 because then I don't have to draw as many loops. So that's 170 degrees. And then if we subtract, we do 170 and we subtract another full rotation, that should give us our negative coterminal angle. So that's negative 190. So it goes like this. And there you go. So you can see that finding coterminal angles is actually going to be really useful when we're trying to work with angles that are much larger. So instead of working with, say, 500 degrees, I'm always going to find a nice coterminal angle that I know where it falls. So 140 would be much easier. Again, instead of working with 1,250 degrees, I would much rather work with 170. And since they fall in the same location, they actually act exactly the same. So again, you can always find a coterminal angle by simply adding or subtracting 360 degrees as many times as you need. All right, so now we're going to talk about just some commonly used angles around our circle. And those are going to be the angles 30 degrees, 45 degrees, and 60 degrees with spread throughout all of our quadrants. So you'll notice, oh, those come from our special right triangle. So again, these are angles that are really common in trigonometry that we're going to be working with a lot. So we're going to see if we can kind of use logic to space out those measurements throughout our circle. So let's start with some measurements again that we already know. And we'll just work in the positive direction. So we know this is 0, this is 90, this is 180, 270, and then 360. So one really common angle we like to work with is 60 degrees, and it's 60 degrees in each quadrant. So if I start at 0 and I add 60, it falls right about to here, 60. And if I add 60 again, it gives us 120. If I add 60 again, it's 180. If I add 60 again, it's here to 240. And then if I add 60 again, it's 300. And if I add again, it brings us to 360. Okay, so these angles, I call all of these, I'll put it maybe in quotes or when I say it, these are kind of our 60-degree angles. So these you're going to see in later lessons. They all kind of act the same. I call these our 60-degree angles. Okay, so 60, 120, 240, and 300. Now let's do 45 degrees. So imagine we add 45 degrees. It's the one right in the middle, right? Because it's halfway between 0 and 90. So if I add 45 from 0, I'm right here. So this is 45 degrees. If I add 45, that gives me 90. Then I add 45 again, that's 135 degrees. And then I add it again, and I'm at 180. If I add it again, I'm at 225. Plus 45 gives us 270. Plus 45 gives us 315. And then if you add again, it brings us back to 360. So I call these our 45-degree angles. So you'll notice that they're right in the middle of all 4 of our quadrants, and those all are going to be grouped together in future lessons, and they all kind of act the same. And then last is our 30 degrees. So again, add 30, and it brings us here. And then we have 60, 90, 120, and then here we have 150, and then 180, and then one more, then we have 210. A lot of the rest are filled in, 240, 270, 300, and then our last one is 330 degrees. So I call these our 30-degree angles. Notice that it's all of your angles that are closest to your x-axis, so here and here. So again, in future lessons, these are going to be grouped together. So again, these are just commonly used angles that we're going to be working with a lot in this trigonometry unit, so it's important that you know how to place them around your circle. All right, that is all for today's lesson. Thank you so much for watching.